Good morning again. So last time we saw resistances in series and parallel. So just to stress on the fact that understanding resistances in parallel is very important. So if I have two resistors connected in this way, I want to check whether they are in series or parallel. Let's say they are connected like this. I am measuring from this side. This is R1, this is R2. So what will happen? These two are the terminals. They are connected to one common point, say A. The other terminals are connected to say other common point B. So they are said to be in parallel. So when terminals of a resistor are connected to one common point and other terminals of the same resistors are connected to other common point, we say that the resistors are in parallel. So next topic we will revise is Kirchoff's voltage law, KVL. So what is it? I'll just go through it a bit faster. Summation of V plus summation of IR equal to 0. That is what the algebraic sum of all the voltages and algebraic sum of product of current and resistances in a closed loop or a mesh is 0. Now what do you mean by algebraic? Means we consider positive as well as negative sign. So how to go about this? So let's take a simple example. I have a simple circuit of 1 volt voltage source and 1 ohm resistance. So I want to find current supplied by the battery. What is the simplest way you can solve this? You can use Ohm's law, V equal to IR, so I equal to V by R. So I is equal to how much? 1 by 1, which is 1 ampere, right? But see, I want to solve using Kirchoff's voltage law. So what I can do? So again I will draw it here. So this was 1 volt, this is 1 ohms. So I want to solve using KCL. So what we do? Mesh analysis. We first consider a current flowing inside the loop. What is a loop? Something which is closed is called as a loop, right? That is, if I start from a point A, I travel like this, I again come back to the same point, then it is called as what? Loop, right? So I am considering a clockwise current. If you want, you can take it anti-clockwise, but usually we take it as clockwise. Let's say this current is I1. So I want to find the current supplied by the battery. And can I say that the current supplied by the battery, since this is a single loop, it is same as I1, right? So I want to find, in short, I1 only, right? So what we do is we next assign polarities for KVL. So what will be the polarities? Obviously this is a voltage source, so this will be positive, this will be negative. Now how is current flowing here? Clockwise, means towards right. So current, always remember, current flows from higher potential to lower potential. It is like water, it will go from up to down only, not from down to up. In the sense that higher potential to lower potential, in that parlance I am talking about. So this will be higher potential, this will be lower potential. If current flows flowing the other way around, this will be plus, this will be minus. This is very important, right? So I can start applying KVL here. So what does KVL say? Summation of V plus summation of IR equal to 0, right? So I start from say point A. So I am going upwards. So I should reach a point A again. So I should use this path. So I should go like this, clockwise. So what do you have to write? Applying KVL to loop A. Let's say this is B, C, D. A, B, C, D, A. We are reaching A again. So what do you encounter? From A to B, there is a voltage source and we are going from minus to plus. So there is a rise in potential. So plus 1. From B to C, next is BC. So B to C, we are going from plus to minus. So there is fall in potential. So we will use a negative sign because there is a fall in potential. Fall in potential is associated with negative sign. Minus, this is a resistor. So we can't use V. So we will use I into R. So I is how much? I1. Into 1 will give you I1. So 1 minus I1. C to D there is nothing. D to A there is nothing, and we are done. So this should be equal to what? 0. So therefore I1 equal to 1 ampere. Right? Using Ohm's law also we got the same answer. Right? So let's consider two loops now. Let's say there is a voltage source here. So this is 2 volts, this is 3 volts, this is 5 ohms. Let's say all resistors are 5 ohms. And I want to find what current supplied by the 2 volt source battery. Okay. So what I'll do, first step I'll consider arbitrary currents in the clockwise direction, I1 and I2. What is the next step? To assign the polarities. This is a voltage source, so we know it, it's very simple, so assign those first. Then what we are going clockwise. So from here we are going towards right. So this is plus, this is minus, positive to negative. Here we'll see later, it depends on the loop. Here because two currents are involved, so we are not sure. So here for I2 we are going downward, so this is plus, this is minus, right? So I am applying KVL to loop 1. This is I1, so it is loop 1. So applying KVL to loop 1. So let's say I start from here. So I am starting from here. So I should go like this and I will come back here. So then only the loop will be complete. KVL can only be applied to a closed loop. So I go from here, I encounter minus to plus. So there is a rise in potential, so plus 2. So here I go from plus to minus, fall in potential, and it is a resistor, so minus 5 into current is I1. Now here what is happening? I am considering loop 1. So loop 1 has higher precedence. So current is going downwards. So plus, minus. Okay, this be careful over here. So I am going from plus to minus, minus 5 times I1. But what is happening? Through the same 5 ohm resistor, a current I2 is also interfering. But it is in opposite direction as compared to I2. So the current flowing when I am considering loop 1 through 5 ohm resistor is what? I1 minus I2. So it is not only I1, it is I1 minus I2. So it will become what? 5 times I1 minus I2. Here there is nothing, so this will be equal to 0. So then you have to solve this equation. So what we will get? Minus 10 I1 plus 5 I2 equal to minus 2. So this is equation number 1. Then applying KVL to loop 2. Let's say I start from this point. So I go upwards and I should again come to that point, right? So now loop 2 is having precedence. So current is flowing upwards. So now this sign we have to consider, remember, not this sign, because loop 2 has higher precedence now. So I am going from plus to minus, so fall in potential, so minus 5 times again I2 minus I1. I1 is in opposite direction as compared to I1. So minus 5 times I2 minus I1. This is plus 3. I hope you have got now. So I'll write directly. This is going from plus to minus. So minus 5 I2 equal to 0. So this will be 5 I1 minus 5 I2 minus 5 I2 minus 10 I2 equal to minus 3. Right. So I have two equations. What I can do, I can solve them simultaneously. Right. What is this? Minus 10, 5, minus 2. Remember, I have taken first I1, then I2. So here also I should have I1, I2. If you write this as minus 10 I2 plus 5 I1 equal to minus 3, then you will enter here what? Minus 10 and plus 5. Then you will get a wrong answer. So this should be also I1 and I2 if this is I1 and I2. So 5 minus 10 minus 3. So I want what? Current supplied by 2 volts. So I want I1. So I1 is how much? 7 by 15. So I1 is how much? 0.4667. 0.4667 amperes. Again, as I told yesterday, at least 3 decimal places. Right? Let's go to a sum which has 3 loops. So before that, what is the difference between loop and a mesh? So if you consider this loop, this is a closed thing, so this is a loop. If you observe, there are some two loops, at least two loops inside it, right? So it cannot be a mesh, so it will be a loop only. But if you consider this loop, do you have any loop within it? No. So this is called as a mesh. Similarly, this is a mesh. This is a mesh. So there are how many meshes? 3 meshes. So you'll require 3 equations to solve using KVL. So number of equations is equal to number of meshes. Remember, number of meshes, not number of loops. So let's say I have to solve this and I want to find current through 2 ohms resistor. Okay. So what I'll do first, again I'll assign clockwise currents I1, I2, I3. Right? So I'll assign polarities. So first assign 2, this is minus, this is plus. Then this is minus, this is plus, this is plus, this is minus. I am going in clockwise direction from left to right, so this is plus minus. When I apply KVL considering first loop, this will be plus minus, this will be plus minus. When I apply KVL considering second loop, this will be plus minus, this will be plus minus. When I apply KVL for 3 ohms using second loop, this will be plus minus. Similarly here, this will be plus minus and this will be plus minus. Remember, this we have to consider for third loop, this for second loop, and this two for first loop. So every time you have to write first applying KVL to mesh 1 or loop 1 will also do. So I am starting from here, I am going upwards, I should come back here. What should be my path? This, because this is mesh 1. So applying KVL to mesh 1, minus to plus 10 minus I1 minus 3 times, what will this be? Minus 3 times I1 and I2 is interfering and I2 is in opposite direction. So minus 3 times I1 minus I2. Similarly, this will be what? Minus 6 times I1 minus I3. Right? So then you can solve this. First I'll write for mesh 2 and mesh 3. So mesh 2 is what? Here. Let's say I start from this point. So I am going like this. I should come back here. So plus 2 minus. So minus 2 times I2 minus 5 I2 minus 5 minus 3 times I2 minus I1 equal to 0. Then for mesh 3, what will we get? I start from this point. You can start from any point. I am arbitrarily taking any point. You can start from any point. So I am starting from here. I am applying KVL to mesh 3. So for 6 ohms, this polarities will be having precedence. Minus 6 times I3 minus I1 plus 5 minus 4 I3 plus 20 equal to 0. Right? Now you are not in first year, so you already have a basic knowledge of BW. So after this, there is no need to write steps to show these equations. You can directly write. Okay. For that, I can tell you a very simple method, host and guest method. Let's say we are applying it for first mesh, right? So count, there are how many resistors? 6 resistors, right? So addition of them is how much? 6 plus 3 plus 1, 10. Right? And they are for first mesh. So I write 10 I1. Okay. Then these are for first mesh. What is it sharing with second mesh? How many resistors are shared with second mesh? 1. What is the value of that? 3. Since it is shared, we use negative. Since these were own resistance, so these were positive. So this is minus 3 I2. Again, what is shared with third loop? 6 ohms. So it is shared, so negative. So minus 6 I3 equal to, we are considering clockwise current. So it will be directly voltage source value. Clockwise, you are going from minus to plus. So this will be plus 10. So this will be first equation. If you see this, it will be same. So if you consider this is minus 6 times I1 minus I3. I forgot to write a bracket. So minus 6 I1 minus 3 I1 minus I1. So minus 10 I1. We are getting negative of this. Then I2 is plus 3 I2. We are getting negative of this. I3 is plus 6I3, we are getting negative of this. And this will go here, so it will become minus 10. So we are getting negative of this. So if you multiply this by minus 1, you will get the same equation. Similarly, I apply for second loop. Total number of resistors values is 5 plus 3 plus 2, 10. So this is for what? Second loop. So it will come in middle. So 10I2. How much is shared with first? Minus 3. So minus 3I1 plus 10I2. Shared with second is, third loop is nothing. So 0I3 equal to voltage source. We are going from plus to minus. So minus 5. 2. Equation number 2. Similarly, you can do it here. You will get the same equation. For third one, what is it? 4 plus 6, 10. And it is for third. So 10I3 shared with first minus 6I1. Shared with second nothing. So minus 6I1 plus 10I3 equal to, now there are two voltage sources here. So clockwise direction में minus 2 plus 5 plus 20. So 25. So this is equation number 3. Now just solve them. Remember, don't directly write these three equations and come home. What do you have to do? You have to write the steps. Applying KVL to mesh 1. Then show that you know how to apply KVL. Then you can directly write this. If you directly write these three equations, solve using calci, you might get 2 or 3 marks only out of 10. So make sure you write these steps, and then no need to show the calculations. You are not in 10th standard now to show the steps. But these steps are important. They are testing you on electronics engineering. They are testing you on how to solve a network. So applying KVL to mesh 1, we get this equation. Then directly you can write this equation. Similarly here. So now let's solve this. So 10 minus 3 minus 6. 10 minus 3 minus 6. 10 minus 3. 10. 0. 0I3 is there. I have not written, but you have to consider 0I3. Minus 5. Then minus 6I1, 0I2. So 0, 10, 25. So I1 equal to 4.2727 amperes. I2 equal to 0.782 amperes. I3 equal to 5.064 amperes. What we have to find? This is not your final answer. We have to find current through 2 ohms. This is current through 2 ohms. It will be what? I2 only. So current through 2 ohms equal to I2 equal to 0.782 amperes. You have to show the direction also. Direction is what? Clockwise. So this is your final answer. This is clockwise. This is also clockwise. This is also clockwise. Fine. Thank you.